everyone. My name is Fereshteh Bayat, and today I will be presenting my work on removing biofilm and recovering the sensitivity for biofouling dissolved oxygen sensors using phase treatment. So as we know, biofouling is one of the major challenges for environmental monitoring, especially for underwater measurements. Biofouling actually is the undesirable adhesion and growth of microorganisms on the surface of solid materials, and actually it can affect the operation, maintenance, and data quality of water monitoring sensors. Bacteria are actually the major contributors to biofouling events, and they form a surface-bound three-dimensional communities by secreting the extracellular polymeric substance on the surface. So in this study, as a proof of concept, we chose dissolved oxygen sensors to show that phages can actually effectively remove the biofilm forms on the surface of these, and it can be actually used to recover the signal after biofouling, after treating the biofilm with phage. So dissolved oxygen sensors are among the electrode and membrane-based sensors, which are more susceptible to data drift and also the malfunction due to biofouling. Electrochemical DO sensors are composed of electrode, electrolyte, and also a gas permeable membrane. This membrane allows oxygen to pass through, and it prevents the penetration of other interfering species. When biofouling happens, actually the pores of the membrane can get blocked, and this will lead to inaccurate DO measurements. So there are different methods to clean the surface of the membranes, and they are mostly using harsh chemical treatments or mechanical treatments, which will actually damage the surface of the sensor, of the membrane surface, which is actually a sensitive, delicate surface most of the time. So bacteriophages have been proposed and explored as potential biological tools to control and mitigate biofilm formation on the surfaces in different settings. So as we know, lytic bacteriophages are mostly used, and here you see the life cycle of phages, which are mainly lytic and lysogenic. So we are mostly interested in lytic bacteriophages, because they can actually lead to lysis of bacteria and kill bacteria afterwards. So in this study, we used a mixture of lytic bacteriophages. We chose two broad host range Pseudomonas phages. You see the name of the phages on the screen to remove the fully developed biofilm of Pseudomonas aeruginosa. So we chose a commonly lab strain PA01. So as you see in the schematic here, we took the baseline measurements first, then we started growing biofilm on the surface of the membrane for 4 days, and then we treated the membranes with phage for different times, and also we had control in LV media. And after a phage treatment and also keeping the control in LV, we did the measurements and we quantified the results. So first, we looked into the biomass increase on the surface of the membrane after 1 day, 2 days, 3 and 4 days. So as you see here, we quantified the biomass using crystal violet assay. So after 1 day, actually bacterial cells will attach to the surface. Then in the next step of biofilm formation, they will spread along the surface, and by secreting the extracellular polymeric substance, they will actually form a 3D structure. And after 4 days, we will have a full maturation of the biofilm. So you see that the water channels are formed, and we have a thick layer of fully matured biofilm on the surface of the membrane. So we chose 4 days for this work. And after 4-day biofilm growth, we treated the membranes with phage. So we put the membranes, fully grown biofilms on the surface of the membrane inside phage solution. And then after 6-hour phase treatment and overnight phase treatment, we quantified the biomass with fluorescent dye stain called Fauché. So we stained the biomass for the biofilm membrane and for phase-treated membrane. So as you see in the fluorescent microscopy images, the biofilm mass decreases after 6-hour phase treatment, but overnight phase treatment was actually more effective in decreasing the biofilm mass. So we also use SEM imaging to observe the surface of the clean, biofilm, and phase-treated membrane. So as you see, this mature biofilm, 3D structure of the biofilm is decreased significantly after phase treatment. There are still some debris remain on the surface, but it has been able to successfully remove the 3D structure of the biofilm with phase treatment. So we use these membranes to measure the dissolved oxygen concentration. We also had a control. So we used also bleach to treat the membrane, and we wanted to see the difference between phase-treated membranes and also bleached membranes. So as you see here, after biofouling, the signal, the DO concentration, and that we are able to measure in water decreased significantly. So by phase treatment, the signal was recovered and it was almost comparable to the clean membrane. So with just single treatment with phage, we were able to recover the DO concentration signal. So the bleached membranes were not the results. Using bleached membranes were not consistent. So it also damages the surface of the membrane, and it also is not environmentally friendly. So phage treatment is a more better way to cleaning the surface of the membrane. So the response time of the sensor was also affected by biofouling, and it was recovered by phage treatment. So after 24 hours of the treatment of the surface of the biofilm membrane, we were able to recover the response time as well. And as you see, the results of the phase-treated membranes was comparable to the clean membrane. So in summary, we were able to show that biofouling can decrease the CO sensor signal by 32% and increase the response time by 90%, by around 90%. So the sensor signal for water that had augmented by 32% for a fully biofoul membrane was returned to the original value after phase treatment. And also the response time of phase-treated membranes was comparable to the response time of a clean sensor. So we were able to show the near complete regeneration and signal recovery for dissolved oxygen without using any harsh chemicals that could destroy the fragile sensor membrane. And thank you for your attention.